happened.
Is it? There it is. You're live.
Hello, David.
Evening, guys.
Hey, Rock. You're the guy I want to talk to tonight, too, because I need a chemist. Uh, okay. So I think Lars screwed us up by putting an icon on there. So when I tried to go live, it just went spinny thingy. we managed to get it up. Well, you said you're a geochemist, so we'll see. Uh, anyhow, let me give everyone a little bit of a chance to get their feet under them right now. Couple things. Going to go over some results from our testing so far at the lab and show you what we found, some of the complications we got going, and what we need to try and figure out a way around. Sounds good, Rock. And we are going to later on, or anytime you want, if you can put a suggestion in the comments thing. There's a TV show from out of London.
Let me get in the bathroom here. They're on their live stream.
They're looking to put together another gold mining show, but they want to make it about micro scale mining operations where they move around a bit and interesting legends or historical things or whatever, historical characters, stuff like that. So if you have a suggestion, you think this would be a good thing to do an episode or a segment on, if you could just put it in all caps. I'm going to tell the lady who's putting on, just go back. Right now it's like 2:00 in the morning there, so it's not good. And, and just, I'll tell her, you can just scroll through the comments and see the various things that people came up with. So if you have, say, a good micro scale mining operation somebody's doing,
Yep.
or anything like that, just go ahead and put it in the comments section. And I also found out that through some personal contacts that apparently the electric company here is packing up all of their spare parts, transformers, switches, and stuff, putting them on a train and sending it to be shipped to Ukraine so that we'll have nothing. I was rather annoyed with this, went down with this information, went to the Capitol building today, left a comment at Hello Argonaut with the governor's office. We'll see what they get back to us. I don't even know if they know this is happening. I don't even know for sure myself that it is, but I trust the source pretty well. So, yeah, what we really need to do is take all the stuff we're keeping for emergencies and give it someplace else so the Russians can blow it up. Yeah, that's going to work out well. By the way, for those of you who don't know, the what do you call order time right now for just ordinary transformers like you'd use is about 5 years due to all the COVID screw ups and stuff.
Hurricanes and all kinds of things over the last few years.
Yeah, between all of that, the lead time, exactly. It's about 5 years.
Yeah,
so
ice storms.
And we have a good ice storm or something, we're going to be screwed here in Montana. So, we're not happy. So let me get to the laboratory results here. Now, Tricky Dicky from the Philippines sent us a paper that had 3 different elution or stripping, whatever you want to call it, processes for a resin. You would think so, Rock. That's not the impression I got from the information I got, though. Okay, that's why I want to check. It was like, no, we're just packing everything up and shipping it off. That's not what I want to hear. Now, they may be being selective. We shall see.
I have no idea.
But anyhow.
But anyway, that's how that went. I have no idea either.
Anyhow, so he's not here yet, Rock. So anyhow, I mean, Russia's running out of targets. They need to make some more targets for them. I mean, it's not going to last long. Goodness. Yeah, the Ukraine needs it all right, but first they need peace. Hi, Scotty.
Yeah,
So-
hey, Scotty.
Anyhow, this process, it was a paper that was dealing with strong base anion resins and selective stripping for mercury, silver, and gold. It had a 3-stage process. Now,
Well, let me try
stage 1
holding it and
was sulfuric
maybe I'll
acid.
try a different vibe and see if it helps.
The second solution was hydrochloric acid and salt. The third solution was sodium hydroxide, salt, and sodium hypochlorite. So we tried this, and the first time we did the 3 stages, all 3 stages, these were the results here. This is A. The sulfuric acid did not get any gold out of the resin based on fire assaying a smaller batch of the resin. Okay. The hydrochloric acid and sodium chloride didn't get any gold out of the resin, and they were not supposed to. But what you would call the gold stripping solution only got 15% of the gold out of the resin. Now, the interesting thing was when we took samples of resin and ashed, actually, don't know here. Okay. And that was no there. Yeah. Okay. So when we took samples and ashed half of it and then fire assayed the other half and compared the fire assay of the ashes to the fire assay of the unashed resin, we got no losses. Okay. So it looks like we had done something that stabilized the resin for ashing, so we could ash it with no losses, which would be a breakthrough. In a previous test where we only used the 3rd stage, we also got the same result here, although we did not see any loss in the gold as the fire assays of the resin showed. Okay, so we decided, okay, we'll try and do this again with a larger batch of resin so we can do both of these tests on samples that we pull out. After each step, we'll pull out 50 grams, dry it, split it. Okay, we're partially through that, thus these question marks here. However, something very interesting happened. After the stage 1 with resin B, after we rinsed the beads and everything, we were getting this blue precipitate, very brilliant blue. The beads that we dried to assay were this brilliant blue with little gold flecks on them. It's like, okay, that's interesting. I mean, Eva used her typical exclamation and such things. Holy guacamole, look at this.
Yeah. Oh boy.
But anyhow, so that's the blue stuff is what the picture is on the thumbnail, although the lighting was very difficult to get the color. I'll tell you what we think it is in a moment. But the other interesting thing was this first solution pulled out apparently 50% of the gold, because when the original resin here, resin B, had 0.41 gram bead with 25 grams, with a 25 gram wet sample. This one here had like a 0.212 in a 50 gram sample. So, I mean, half the gold disappeared, presumably into the solution. We haven't had that analyzed yet. If so, will have been by far the best recovery of gold into solution from any of the solutions we've tested, but yet on this one, it made absolutely no difference. This is getting very annoying. Okay. Anyhow, then when Eva went and did
This is good.
take the sample of resin here and ashed half of it and just assayed the other, the ashed sample actually had a higher gold weight than the non-ashed sample, significantly by about 10%. Okay.
Holy shit. Okay.
So that's why it says negative here. It actually, the ashing seemed to actually create an improvement. Talking with Chris,
Well, that's-
looking at the
you know,
characteristics,
I mean,
we have a
these things are
really
coming
bright
together.
blue
Got a
precipitate,
time frame and a schedule
and it's
now, and
insoluble.
you got a new vehicle, so you know
You're making a lot of noise, little one.
Sorry.
Okay, you can sit in the bathroom. That's what I do. But anyhow, it's a very bright blue, and it's insoluble. When you let things settle, it all winds up on the bottom of the beaker, and the solution is yellow. Okay, it's
Whoa.
kind of like urine if you haven't been drinking
Right.
quite enough water. It's about that color. And each stage, we wound up with more of that blue precipitate, or at least what appears to be the blue precipitate. We think the precipitate is likely to be something called Prussian blue, which is ferric ferrocyanide. We do have ferrocyanide ions in the Eco Goldex. So we have a known source of ferrocyanide ions. There's obviously iron. This ore has iron up the wazoo. How we converted it into Prussian blue, and why it worked with resin B but not resin A.
That's an interesting
Good
question.
question.
Rock Butcher asks, what's sample A and B? What are the two differences there?
Okay.
One was-
Sample A and sample B. When we are this fall, when we were processing rock, what we would do is mine a batch of rock, haul it to the crushing at the mill, leach it, dump it on the pad, and then we'll collect the solution from that, and then send that through the resin. Oops, R-E-S-I-N.
Mhm.
So essentially, each batch of resin that we have is highly dependent on what batch of ore we crushed just before that and leached. So it can be extremely variable in terms of exactly what rock we're looking at. Although it's all from the same vein, except for the last batch came from the dump. But so it's going to be somewhat different in chemistry and concentration depending on this ore and how much we recirculated at a particular time. But we were getting about 1 cartridge of loaded resin for each batch that we ran through, Rock. And correct, Rock, essentially. Okay, Rock, whine. No, A is resin sample A. And these are two things, two different tests. Okay. So in this case, resin A had no gold
What's your
loss.
A and what's your B? What's
Yeah.
the difference here?
They're 2 batches of resin.
Okay.
Okay.
That's what he's
From
trying to
2
figure.
entirely batches of ore. Okay. So resin A, we had no gold losses to solution that we could detect. Resin B, using the same process, we had 50% gold loss apparently into solution. Okay. And this would be gold loss from ashing. In other words, if you take you take one sample, dry it, split it, and then ash one, and then fire assay the ashes and fire assay the other sample of resin. That's what we're talking about here. The original method we were planning on doing for processing the resin was ashing it and then smelting it. unfortunately, we ran into very high losses during the ashing and drying processes. So even when we figured out how to keep from losing it during drying, we were still having problems with ashing. So, I mean, we're losing 25 to 50% during ashing. So this particular leach here seems to do well on the no losses bit. We have one we did only this to, one we did after these previous two. In both cases, we had no losses there. In this case, on resin sample B that came up with the blue stuff, the ash sample actually had more gold in it than the just straight fire assay of the resin. Yeah, Tricky, I'm glad to hear that too. Between what happens between the two tests, the resin. That's the only change. Resin batch A and resin batch B were from different batches of ore.
2 weeks apart.
2 weeks apart, and they reacted radically differently, you know?
And A was actually from the dump piles. I'm 99% sure on that.
I don't know about that. But anyhow, so this is, you know, it's like, wow, what a big difference. As you know, Rock will tell you, and anyone else is worried, everything is ore dependent. And sometimes that depends on the ore right here or the ore 2 feet from it or whatever.
Right.
So, and like that comment there. So anyhow, that's kind of where we're at the thing. We still got these tests in progress over here. These tests cannot be done now. So they're just, you know, not going to get any results on that. That's why we were doing another test. And then we're probably going to start on a third batch of resin. Again, a separate batch of resin, see what happens. See my comment on what changed me. The gold loss from resin test. What changed? Nothing that we did. It was the exact same amount of resin, same solution, same time, same temperature, same everything. The difference was this one did not have that blue precipitate. It had more of a black precipitate. This had a very brilliant blue precipitate. Look up Prussian blue. That's the color. That's one reason we think. But anyhow, exactly, David. And some more.
And more.
So anyhow, one question I have, and maybe you can answer Rock or Chris or somebody else. Prussian blue appears to be insoluble in your standard acids and water. But I read one thing that seemed to indicate that if you mix it with weak alkalis, you'll get an exchange of the ions and you wind up with a soluble hydroxide, iron hydroxide,
Ferrocyanide,
and the concomitant ferrocyanide. And what Chris is saying, he thinks that if you mix it with ammonium hydroxide, you're going to wind up with iron hydroxide and ammonium ferrocyanide. And so you can dissolve it, okay? Because we were seeing on those beads look like blue powder coat and little flecks of gold, okay? That's correct, Jeff. Room temperature, air drying. And I say everything was the same except the actual resin itself. Everything else was done exactly the same. And yet we got radically different results, which tells us there was something different in the resin, you know?
or in the ore.
Well, yeah,
Yeah.
came from the ore, you know, but
Or
something
coming from the ore.
something was different in the ore, most likely.
Right.
I can't see any reason why it wouldn't be something in the ore that wound up in the resin. But it's very, yeah. Test for Prussian blue, Tricky, because that's what we ran into. I was originally thinking it might be copper sulfate. I know we have copper.
That would move. You'd be able to.
We've got sulfuric acid, so it's like blue, but it was not soluble. Copper sulfate's pretty darn soluble.
Yeah, you'd be able to move that.
Yeah, it shouldn't be too hard. I am not sure. We have the records. Eva seems to think that the A batch was from the dump and the B batch was from the mine. However, it's my recollection that the dump stuff was done in late October.
Later on.
Yeah, later on. This was in September, so
I will look it up in the record.
but we do have the records.
Yeah, you're going to need that.
I'll be able to tell you exactly where it came
She's
from.
been very good at writing a lot of stuff down. It's not all on the same sheet though.
Right.
There's so much data. No, not the lot number of the resin, the batch of solution that went through that particular batch of resin. It's all from the same boxes of resin. So it's the same type of resin, the same batch of resin.
So it's more than likely, David or Jeff, picking it up in the ore. There's picking up something in the ore.
Yeah.
In the resin.
Let me see if it disappears from the chat. I could make you a moderator, Tricky.
Do it.
Okay, you're now a moderator, Tricky. So are you happy now? Celebration time. Okay.
Good time. Come on.
Could be the oxidation state of the iron. Yeah, I say.
Very possible, Chris.
Yeah, I think my belief, although I don't have the records in front of me, is that in fact they were basically just different batches as we were going down the vein. Don't know for sure.
Well, if it was, that would be down around the 25-foot level, and the other one would be around 23.
Yeah, something like that. Yes, I agree, Chris. I do not think that's the case, but we will be double checking that. So anyhow, that's kind of what we're interested in. And Chris is suggesting ammonium hydroxide, which I do not have. Is there any reason sodium hydroxide wouldn't work? Because we have plenty of sodium hydroxide. We have calcium hydroxide too, but I hate to use it because it's only so soluble and tends to make, sludge. Yeah, pretty much. We got to go back and check a few records and stuff. But to my recollection, in September, all we were doing was just continuing down the shaft. We didn't divert until towards the end of October, where we were rushing the cold.
Right,
and I went
grab up a rock.
Yeah, I went to grab that rock. So, what freshness is, by that he means how close to surface and how exposed to weathering it is. If it's right on surface, it's been quite exposed to weathering. If it's 20 feet down in solid rock, it hasn't been nearly exposed to as much oxygen or water or things like that. And so that's what he means by freshness. He basically means, is stuff weathered or unweathered? Yep. So that's what we're talking about. Yeah, Chris, I'm pretty sure it's ore dependent, and it could also be a factor in terms of the resin itself is selectively picking something out of solution, right, for whatever reason.
Temperature.
Yeah.
Who knows?
So, yeah, Shaggy, exactly. And a mine half full of water from the 1800s and the rock 10 feet inside the wall. the stuff 10 feet inside the wall will be much fresher
Right.
than the stuff
Less-
right on the surface.
Less oxidized.
Yeah, less oxidized, less
Other-
water.
Right.
Percolation
Less
through it.
exposure
Yeah.
to everything.
Exactly.
Yeah.
So it's extremely frustrating, but we're learning a lot.
Oh yeah.
The problem with learning a lot is it's because things aren't going well. What's a TANOD? Is that like the local headman, police,
Gestapo.
what? Gestapo?
Gestapo.
Biden administration? Yeah. And is that 1.3 or 13? It looks like there should be a decimal point in there because of the space.
3 kilogram.
We found 1 3
One-
kilo. Oh,
yeah.
one each 3 kilogram. Huh?
Yeah.
Okay. Yeah, I say it's interesting. Eva's working her cute little buns off in the lab, and I'm
Going fishing.
tomorrow. Well, I've gone fishing a couple times, but tomorrow we get thiourea, and the leaching or the elution for the Purigold. You're supposed to use thiourea and a dilute sulfuric acid, not real dilute, but I mean 1 to 10 battery acid, so reasonably dilute. So I'll try that on some max water resin first, just to make sure I got the system figured out and this and that. And that'll give us something else we're trying on it.
Yeah, Rock, that's what I said to Keith. It could have came from a different point in the mine if it's coming off the dump or the dump is mixed enough. Yeah, Tricky's chasing historical gold.
That would be a great video.
That'd be a really good one, but
Make sure you take plenty of video, Tricky, and then when you're
For-
out of the country,
right after you're gone.
yeah, probably, Jeff. It's got decades for sure. How many, I'm not sure, but I'm guessing the latest possibly is like the 1930s. Judging by those timbers, they're in pretty
that'd
good
be
shape.
my guess too, is 30s. So that's 80, 90 years.
So I say, don't know. We do have the records, though. We can figure it out within a couple of feet without too much trouble in each batch. And there is going to be some crosstalk between batches, because if some ion is not being picked up by the resin, it's going to be increasing in concentration over time.
Yeah.
So we'll see what that is going on there. But yeah, Eva's been working pretty hard, doing a great job, and I'll be trying thiourea. I also have an electrolytic cell set up.
I'm working on that.
I was thinking I need something I can put resin in that will kind of contain it while I try and run solution through in this. And I thought paint strainers.
Yeah.
So I got it to where I can clip a paint strainer in the single cell and put the sample in that. And then I've ordered a peristaltic pump.
Ouch. Oh boy.
Yeah.
That made for an exciting week.
That's the problem with these. Oh, wait a minute. We live in one now, right?
Yeah.
Yeah, they can send the
we're-
secret
yeah,
police
we're-
after you. Yeah.
Yeah, we're in about the same shape.
So, anyhow, let's see. Do I have a like button? I don't think I have a like button.
Thanks,
Do I?
thanks, Mr. Lodak and Rock Butcher.
Yeah.
Yeah.
But
I don't think YouTube wants to count.
yeah. So anyhow, as I say, I've also designed it so that Lauren has some sheet stainless and a plasma cutter.
Yeah.
So he's going to get me 2 flat electrodes that basically take up the whole cell. And I got a 3M pad as a divider so they can't short out. Sounds good. They're probably not smart enough to figure it out.
That's a good plan.
Yep. Anyhow, but I also had to make one electrode which will basically fit inside one of those conical filters. And so I can put it inside the filter, dump the resin next to it, and it's right up against that electrode while still being contained. And I can kind of try and drive electrolytically the gold or whatever else is on the resin off of it.
Sure.
So we got a lot of ways we can experiment, and pretty good shape. So I've got lots of fun things to try here in the not too distant future. And which is good because I was getting a little bored because Eva, she's working her buns off, but she's got this little furnace.
Yeah.
So she can
it's
only
time,
move so
yeah,
fast. She can
time
get about
critical,
2 samples a day done.
Yeah.
And I can make a lot more crap than that, you know? So I'm just kind of dawdling along comparatively. And my body doesn't deal with sitting around real well.
No,
I get fidgety
gotta
and,
be doing something.
and depressed. Yep. So anyhow, should have some interesting stuff. This is why we didn't have a video out, because we're right in the middle of all this stuff going, what the hell is going on? Another thing we can do is we can take a sample of that material to the lab and have them analyze it.
You may have to.
This solution from right here, this test, that needs to go to the lab. Half the gold seems to have disappeared. That kind of variance is not what you would expect from sample variance and things like that. Yeah, 2 to 5% you just kind of ignore.
Yeah.
That'd be nice, Rock. Then we need to keep it up so that we can pay Lauren for the electric bill or the fuel bill, whatever.
Yeah, right.
Yeah, fuel wouldn't be bad because that'd be propane. We could buy that.
Yeah, that could,
if it was a
be
propane
easily.
furnace. Yep. We may actually have one sitting in Anacortes that we have to go get. I'll have to talk to Max about that. He offered it to me last year, and I just haven't gotten over there. Okay, Rock, that's a good question. This right here says in the original resin sample, before we treated it, Eva got 0.41 grams of gold from 25 grams of wet resin using her standard fire assay technique. And when she took the treated resin and just fire assayed the wet, 25 gram wet, that had been dried.
0.28. I got 0.32 on the other one.
Okay.
That
So
was the beads.
it was more like 40% losses. But that's why, it's because the fire assay of the resin changed dramatically. And it's like, where could it go? Solution would be, it could be in the precipitate.
Yeah.
It could
Yeah.
also have not fully reduced into a lead button. My buttons are the right size, but we did have some dendritic gold that showed up in my slag, which is why the slag is reserved.
It could also have been something where it messed up the fire assay procedure somewhat. Is it truly gone or just in solution? My guess would be in solution or precipitates somewhere.
Or in the slag.
And which we have retained both. So we haven't thrown anything away because we're like, okay, this is confusing.
I also keep all my slag, and I also make sure that my crucibles come out clean.
And she also said she noticed some dendritic gold in the crucible from that sample. So it may have been lost there. Hard to tell.
Maybe 1/100 of a gram.
But I don't think it's gone. It's simply
Moved.
somewhere else in the system.
It moved.
This is not necessarily bad, though. I mean, if we got
If you could get it
40%
out, right.
into solution, and then electro win it out, well, if it keeps going into solution, well, that's pretty simple.
Right.
Sulfuric acid, yeah, that's pretty easy to get to. Agreed, Rock. But as I say, the flux recipe's been working really good up till this sample. So again, this resin may have changed things to where we need to change the flux recipe, but I agree with you completely. Could also need a further, maybe a longer smelt time or something. She also had one sample, the scale that she used to make the charge, apparently started
Oh,
crapping
yeah,
out
you were telling me about
because we
that,
wound up
yeah.
with an 80-gram
Button
button
lead
when there's only supposed to be 60 grams of litho.
85
Oh, yeah.
gram.
Yeah, and
That one actually had good recovery.
yeah, I don't think we've seen much in the way of beads and slag, but we have seen dendrites before.
I have never seen beads in my lead slide. Lead beads.
But anyhow, now, yeah. Anyhow, whatever. Okay, she measures the resin beads only on the milligram scale, so that scale wouldn't have affected that, but it did seem to actually get a bit better recovery. So we may need to put more oxidizer in there too. We're planning some tests where we add more potassium nitrate and see if we're not getting full reduction. I mean, we're getting full reduction of the lead, but are we getting full oxidation of the resin? So, yeah, she looks at all the slag pretty carefully, and I say we don't see beads in the slag, not lead, not gold.
Any metal. that's-
Occasionally, we have seen dendritic gold on the sides of the crucibles. Yeah,
Wow.
it sounds a little more exciting than I want for, normal stuff. But as I suggested, remote operated vehicle.
Yeah.
See, that's my thought.
Yeah, something to get around the minefield.
Yep. So anyhow, that's kind of where we're at right now. We've lost some gold somewhere, but we don't think it's disappeared out of the system. We're just not sure where it went in the system and why it didn't work like this one here. This one here worked beautifully, except for this last one where we had, again, a 15% loss in the fire assay of the resin, which it matched. In this case, it matched the ash thing too. So it's like, okay, they both lost the same amount. It seems unlikely.
Right.
What seems likely is the resin itself lost that much during this elution process. After all, it's supposed to get gold out of the resin. That's
Right.
its purpose. It just didn't seem
Right.
to do a
You're
real
trying
good
to
job.
strip it. Yeah.
Yeah. And so say this didn't surprise us. That and that, it's like, okay, it actually did some elution here. We might be able to put an electrochemical, an electroplating cell in there and cycle it and
Take
make
it
something work.
Right.
But
That's
we shall see. But this is a totally different story. But yeah, and I say, and right here, these two, the fire assay before and after the treatment were identical. Within 1 or 2%.
right. Within a
So
point.
it leads you to believe, okay, the procedure is consistent, even with a somewhat different resin, because you've treated it with something. It's still doing exactly the same thing. Not over there. Yeah. I don't think so, David. Say that one, the scale we think screwed up, because then later on she's like, okay, the number's changing.
Numbers going up.
Yeah, it's like no,
No,
and we've just put
something's-
fresh batteries in it too.
Yeah, something's not good there.
So that scale, I asked Lauren, you want a scale that's not working to play with? And he's like, sure, put it on that shelf.
Oh my word.
What?
If you Google on Google the word Illuminati backwards,
Yeah.
it redirects to the National Security Agency. Holy guacamole! Only works on Google, folks.
Exactly, Rock. However, the scale that went wonky was only used for measuring the flux recipe, not the resin. The resin was scaled using a milligram balance. It's a different balance, different room, and it's plugged in, so batteries are not an issue with that.
And windscreened.
And it's got the windscreen and all that other
that's
stuff.
that's pretty nice scale there.
You know, so the resins, the amount of resin should be the same. However, since extra litharge, and you can't get extra lead without extra litharge,
Right.
seem to have improved the recovery. So we need
Shall
to
be further
investigate
explored.
that. Absolutely, it will change. But it seemed to change for the better, Rock. And that particular sample that came out all wonky, it seemed to do better, which is okay. So what can we do to, this? So yeah, that deserves more investigation. Also, uh, this would be nice if Eva had a big furnace and lots of crucibles and stuff.
Well, yeah, you could run a lot more samples
Yeah.
at a time.
Yep.
Absolutely.
Yeah, you were absolutely right, Rock. The flux recipe had to have changed because, as I say, you can't get an 85 gram lead button from 60 grams of litharge. It would be, if you could, and we were transmuting, that could be worth money. But yeah.
Especially if the gold increases, right?
Yeah, it'd be nice if we had tens of thousands of dollars to set up a lab. But we don't. So we're doing it fairly modestly, and that leads to some uncertainties, but you should be able to keep it
You're
within reasonable ranges. So say that.
you're thinning it one thing at a time.
Yeah.
You're getting that much closer.
Well, again, that scale is now no longer in service. Possibly, Shaggy.
In more ways than one, maybe, Shaggy, at the rate we're going.
It's going to get interesting.
It might be epic before spring gets here.
That would be great, Rock. Eva would probably stop at the silver. A good one, Jeff. I think you got the best comment of the night so far.
Yeah, top comment.
Yep. But I'd say that's kind of where we're at. We're in the middle of a lot of things. We don't have conclusions yet. Yeah, exactly.
Me. Yeah.
But
Might be how the luck goes.
we're getting interesting data, which is probably useful data. Would be more useful if we knew more of what we were doing.
Yeah, just to try to keep it so you can keep going back to look at, okay, we already tried that. You got to be able to get the, eliminate parts of the process.
But what I'm thinking may have happened here is that for whatever reason, because of the other stuff in the resin, the sulfuric acid was precipitating Prussian blue, and some of those ferrocyanide ions were gold ferrocyanide. And so they wound up making those little gold sparks because they looked like little gold, crystals sort of thing. They were irregular, but they were angular. They didn't look like just little dots of light. They looked like they had shapes. They were a buttery yellow and shiny. Okay. It's not like sulfur that's yellow.
Right.
It's like gold. So what may have happened is this may have been precipitating some of the gold also.
Yeah.
Now, if this has happened, then we might be able to work out a chemistry where we put the resin in it and it precipitates Prussian blue and gold. And then we just take that and put it in a thing where the Prussian blue dissolves. Now we got the gold sitting on the bottom.
Right.
I don't know.
Yeah.
Could be tricky. We don't have any that we know of, but it's really, really hard to tell. Exactly, David.
Yeah.
But when you're looking at something in a system like that, that's yellow, metallic, shiny, there's very few things that can imitate that.
Especially can be left at that point.
What if you filtered the Prussian blue to recover the gold? the Prussian blue will tend to form very, very fine particles. Not sure what size the particles are of the gold. They looked, on the beads, they looked bigger than the powder coat particle size, basically. So that's a possibility, but you might be losing a lot of gold too. I don't know.
It's more
That's something that might work. And say I'd like to be able to just dissolve the ferrocyanide, the Prussian blue out of
I
there
think
entirely.
That's what you're going to end up having.
Then you wind up with a solid that you can filter efficiently and then just flux it down. Put some copper in it and leave it for a few days and then filter it. Depends on whether the gold is in the solution or in the precipitates, because the Prussian blue is not dissolved in this solution. It forms a very fine precipitate. You let it sit for a couple days, it's all on the bottom.
It settles.
It's yellow now, a clear yellow. We'll have to see where the gold is, Rock. I don't know if there's any in solution, there's any in the precipitate, there's in both.
Hey, maybe Rock could answer this.
What?
Can we smelt and flux the precipitate?
Can we
How do we go about doing
can
that?
we smelt and flux the Prussian blue if it has gold in it? I don't know. We shall see, Tricky. I say if it's mobile, possibly. We could also take the solution as it's being eluted and run it through a separate container that's collecting the precipitate. It's moving slowly and winding up, sedimenting out or filtering out there. But we'll just have to see. I don't know if you can just flux Prussian blue with gold in it and get the gold efficiently. If I can get rid of the Prussian blue and have just gold, I'm pretty confident we can flux that efficiently without losses. Don't know. It's very, very annoying. That's what I'm concerned about, Rock. Let's say I'm thinking. And does anyone know if I can use a alkali hydroxide? Sodium hydroxide would be what I'd be looking for in order to convert the Prussian blue to a soluble ferrocyanide, to sodium ferrocyanide, and then insoluble. I don't know if it's insoluble or not. Iron hydroxide? Let's see. Most hydroxides are fairly insoluble. Iron hydroxide. Solubility. See more. Come on. I don't know. 8.0 times 10 to the negative 16th doesn't sound good. Solution. If the solution is not deoxygened and the iron reduced precipitate can vary in color. Precipitates from the poorly soluble in water. Precipitates from the action of iron and hydroxide salts. Although I bet you at that point, if you had iron hydroxide, then you could react it in an acid and turn it into something like iron sulfate or something that would dissolve.
Yeah, separate out.
Yeah. Again, we don't know how we're making the Prussian blue. What the hell is going on here?
More tests.
I say, is it useful or is it something we just need to try and suppress?
Yeah.
For example, if we went straight to this without that,
right?
Can we avoid the Prussian blue? I don't know. HCl, yeah. That's entirely possible, Tricky. I don't know. I know the Prussian blue won't dissolve in HCl. It's apparently insoluble in mineral acids and water and almost anything else. But it said, the little note that I saw said that it's soluble in even weak alkali, even weak alkali hydroxides, like sodium hydroxide or whatever, because it exchanges the ions and forms the iron hydroxide and the soluble thiocyanide, which, for all we know, we can put back into the pond, because that's an active ingredient. If in doubt, cement it out. If you can get it, say right now, it appears that the gold is already cemented out. That's the problem. Those gold flecks aren't solvent, and they aren't dissolved. That's metallic gold, if that's what it is, and it's already cemented. It's easy to see if it's in the solution. An ICP will tell us that. We can just take it to the lab and say, put that through the ICP and see what you get.
I think you may have to do that.
Probably would be the
just
next
to find
test
out
to do.
exactly what you're dealing with.
Yep. But yeah, it's an interesting situation. I also kind of like to wait to do those things until after I've done the next 3 stages completely and have a good idea where stuff
you
is
need
disappearing or
a baseline
not.
of some kind.
Yeah.
And now, if you got enough tests going, you'll get a baseline kind of.
But I mean, we don't know what happened in stage 2. We don't know what happened in stage 3. Therefore, are we looking for gold there that's missing or not?
Right.
So yeah, it's fun. I was talking about in the solution rock. We have a clear yellow solution left over from here. All the precipitate's on the bottom, and we got a nice crystal clear solution. It's just yellow. That should go through an ICP pretty well.
Yep.
The other thing, look at these solutions here. This is what happened when the guy at the lab acidified some solution, I forget what it was, to put it through the ICP. And see what you got?
Blue.
A blue precipitate. See right there? That's actually a precipitate.
Blue. Yeah, that one's very blue.
Yep. So I'm thinking ferrocyanide. Stannous test. I suppose we could try, but I'm not sure the Stannous test will work on this stuff. And I say that's why, for $25 I can take it to a lab and have an ICP done. Stannous, what complex are we talking about? Does Stannous precipitate gold in the ferrocyanide complex?
I believe it does, according to my book. It was under evaporation assays. I have to reread that part.
Yeah. But anyhow, maybe the acid is still too strong and it keeps going back into solution. The gold here, first of all, it's a sulfuric acid solution, so it shouldn't really work very well to dissolve gold to begin with. And this is, I think, half molar or something like that. Basically, it's 1 part battery acid, 10 parts water is roughly what we're talking about. It's not very strong. Well, then I'd have to make some Stannous solution up.
I think we've got some.
But again, So
I know we have the Stannous chloride powder.
Yeah, I think we do.
We've got Stannous solution too, if I remember rightly.
I know we have tin beads that Chris gave us, and I know that Lauren has had Stannous chloride in the past. We've also that solution that we have, I forget the name of it, but that we use for our spot test might work also.
KD3.
Yeah, the KD3 might work too. Don't know. Yeah,
Well,
we just got started here.
We can try a spot test with KD3 real quick when we get to the lab tomorrow.
Wouldn't hurt.
Yeah, write it down.
Yeah.
We can do that
Write
on
it down.
all-
You think
we
I need
can
to
do
write
that
things
on
down to
all-
remember them, whoever you are?